Today we're going to discuss a little bit more about visualization from 3D or 3 dimensions to 2 dimensions, meaning orthographic views. Our previous visualization efforts focused primarily on objects built from uniform cubes. Today, however, we're going to use Siemens NX, and we're going to visualize the orthographic projections of other shapes. Here we have a simple green cylinder that has a hole that goes all the way through it. And what we want to do is have you take a minute and visualize and sketch the front, right, and top orthographic views as seen in this orientation. So if necessary, pause the video and sketch the front orthographic view. The front orthographic view should look something like this. 2 circles projected onto the front plane. Now you don't have to worry about shading in the green between it. That's just a representation of the 3D solid. All right, so now pause the video and take a minute and sketch what you would see in the right side view of this for this object. All right, you should see something that represents this. It should just be a rectangle. So a simple rectangle seen in the right side view. Now hopefully, without taking any more time, just looking at this, you would know that that same rectangle view is what should be created in the top view, except the orientation is slightly different than it would be in the front view, or in the right side view. Okay, so that was pretty easy. Now, what would this object look like if we created a plane, a slicing plane, and we actually used that plane to cut off a portion of this cylinder? So now the question remains is, what would this front view of this 3D object look like? Pause the video and take a few seconds, a minute, to sketch what you think that front view would look like. All right, let's check and see if you did it right. So the front projection should again just be 2 circles. That's what the front projection should look like. Pause the video and take a few seconds to sketch what this object would look like if it were projected onto the right side orthographic plane. All right, if done correctly, your projection should look something like this. And I'm going to turn off the clipping plane so that we're able to see the full projection. So the right side orthographic view should be just 4 lines as seen here, shown in blue. Again, pause the video and take a few minutes and sketch what this object would look like if it were projected onto the top orthographic plane. Here we have what the top view should look like. It's got 2 ellipses and 3 lines. And so let's go and make sure that we can fully understand how we arrived at these projections. So if we go to the front view, sure enough, our two blue lines represent the silhouette of this cylinder. If we go to the right side view, our four lines represent the silhouette of this truncated or sliced cylinder. And going into the top view, sure enough, our two ellipses and our three lines represent the silhouette of this projected object. Okay, that was pretty easy and a lot of fun. Let's pull up another model. This model is, again, somewhat irregular, and it has a hole that runs all the way through this object. So again, pause the video and draw what this object's front orthographic view would look like. It should look something like this. Pause the video and draw what the right orthographic view of this three-dimensional object would look like. Here again, its view, orthographic view, should look something like that. It would have four lines representing the rectangle. It would have a fifth line running right down this edge or crease that you see on the screen. Now take a minute and draw the top orthographic view. It should look something like this. Basically, a vertical rectangle with two additional lines. There would be a line running vertical here where my cursor is moving, and another vertical line over here where my cursor is moving up and down. So once again, fairly basic to come up with those images of the orthographic views. But once again, what if we had defined a clipping plane and used that clipping plane to actually trim away part of this object? Now once again, what we want to do is we want to have you practice sketching what the front orthographic view would look like, what the right orthographic view would look like, and what the top orthographic view would look like. So take a minute, pause the video, draw the front orthographic view, draw the right side orthographic view, and draw the top orthographic view. All right, let's check to see if you have created the three correct orthographic views. The front orthographic view would look just like that. It's taking all of the silhouette outlines and just bringing them forward, normal, to the front orthographic plane. In the right side view, we would have this shape, and again, I'm going to turn off the clipping section. We would have this shape, and when we view it from the side, notice how we have the four lines representing the outline or silhouette. We have a fifth line that represents this hard edge, showing the top plane or surface that gets projected out as an edge onto the right side orthographic view. And finally, let's verify what the top view would look like. The top view is really pretty interesting and quite a bit more involved. And notice again, we have 4 lines that represent the outside perimeter. We have a line that represents an elliptical circle, that represents the opening, the hole. And then we have all of these other interior lines that represent the hard edges or the hard lines between various faces that are seen from the top orthographic view. All right, let's do one more. And this one we're going to do really fast. Here is our object that again has a number of planes. And what we want to do is we want to define another cutting plane to this object. And that cutting plane is normal or parallel to our right side view. And we're going to take away part of the doorstop. And we're left with this simple object. Now with that object, what we want to do is have you pause the video and again sketch the front, right, and top orthographic views. All right, I'm going to turn on all 3 of these orthographic views and allow you to take a minute and check and make sure that you created them correctly. All right, once again, hopefully this has been helpful in allowing you to kind of visualize a 3-dimensional object and in your mind transform it to its orthographic views, front, right, and top, which are the standard orthographic views used in mechanical engineering. All right, make sure that you, if you haven't subscribed to my channel and to my blog, make sure you click on the link to CAD Modeling Hub and make sure you click on the next video in this series that will bring other visualization techniques and help to you. Good luck.